Hi everyone. In this video, we are going to see a problem from Fluid Mechanics R K Bansal book, and myself Dinesh Kumar, Assistant Professor, Department of Chemical Engineering, working in Hindustan College of Engineering and Technology. So this is the problem that we are actually going to see. So this is problem number 6.2 in Fluid Mechanics, written by R K Bansal. A pipe which water is flowing is having a diameter of 20 centimeter and 10 centimeter at the cross sections of 1 and 2 respectively. So the velocity of water at section 1 is given by 4 meter per second. Find the velocity head at sections 1 and 2 and also the rate of discharge. So what I have given is there are two pipes. Sorry, there is a pipe having a diameter of 20 centimeter at one end and 10 centimeter at the other end. Okay, so the velocity of water at section 1 is given as a 4 meter per second. So eventually we know that the velocity will be increased at section 2 as the diameter have been decreased to 10 centimeter. Okay, so what they have asked us is to find out the rate of discharge they have asked. So the rate of discharge will be same at both end. Okay, so that is what we are going to find out. So we are going to write down the given data at initially. Okay, so pipe diameter at one end d1 equal to 20 centimeters, so that we are converting into as a meter. 20 into 10 to the power of minus 3 meter. Pipe diameter at other end, that is 10 centimeter. 10 into 10 to the power of minus 3 meter. Velocity at section d1 v1 equal to 4 meter per second. Okay, so this is the actual diagram. So the flow rate will be from left side to right side. So we don't know the velocity v2 and we don't know the rate of discharge. So this is what we needed to find out actually. Okay, so rate of discharge we needed to find out, velocity head at both ends. So velocity head equal to v square divided by 2g. This is the formula that's what we needed to find out. And rate of discharge is q equal to av. So to find out the velocity head at d1, v1 square divided by 2g. So we know the value of b1, that is what we have written at the given data itself is 4 meter per second. So we know the v1 value as 4. So that 4 square divided by 2 into 9.81. G is a gravity, nothing but a gravity. Okay, so G is a gravity. So G is a gravity. 2 into 9.81. So that velocity it will be 0.815 meter. And the velocity headed d2 is v2 square divided by 2g. But actually we don't know the value of v2. But as per the continuity equation, we know that q equal to a1 v1 equal to a2 v2. In this part, we know the value of v1. Okay, from diameter d1 and d2, we can find out the area of cross section 1 and the area of cross section 2. Okay, so that is what we are actually going to do, and we are simply cancelling out these two things because these two are similar with respect to the numerators and denominators. So d1 square divided by d2 square will be there and v1 will be there. So we know d1 square is 10 to the power of minus 3 meter square. So 0.2 the whole square divided by 0.1 the whole square multiply with 4. So that is 0.04 divided by 0.01, that is multiply with 4. So finally we will get as a 16 meter per second. Okay, we can also simply cancel out these two things, write it directly as a 4. Okay, so that is just simply as it is 10 to the power of minus 2 divided by 10 to the power of minus 2. So it can be cancelled each other. So that is what we have actually done as a 4. Okay, so 4 into 4 will be 16 meter per second. So since we found out the value of v2, okay, we found out the value of velocity 2, velocity at the cross section 2, we can find out the velocity head at the cross section. Okay, so v is 2 equal to v2 square divided by 2g. Again the same formula, but instead we are going to substitute the velocity at cross section 2. So V2 is 16 square, 16 square divided by 2 into 9.81. So the velocity head will be 83.047 meter. So this is the problem that we are trying to see here. And we needed to find out the rate of discharge also. So we already know that Q equal to A1, B1, A2, B2. We have already written it. And we know the value of A1 and V1. So we are just going to directly substitute those values. Uh, that is pi divided by 4 into 0.2 the whole square into 4, that is 3.14 multiplied with 0.04. Okay, so this 4 and this 4 get cancelled each other, so that the value of pi is 3.14 into 0.04. So the value is 0.1256 meter cube per second. So 1 meter cube equal to 1000 liters. So that 0.1256 meter cube per second can be rewritten as 125.6 liters per second. So the rate of discharge in the pipe, the reducing pipe, is 125.6 liters per second, and the velocity head at the cross section 2 is 83.047 meter, and the velocity head at cross section 1 is 0.815 meter, and the velocity at the cross section pipe 2, okay, at the cross section 2 is 16 meter per second. Okay, so this is the problem in 6.2 that they have been actually mentioned in uh, fluid mechanics given written by R K Bansal. Hope everyone understand this problem. Thank you. Hope everyone understand this problem, and if you have any doubts or queries, you can just ping me. That we can find out my mail from our official website, Department of Chemical Engineering. Thank you. Bye bye.